This is Algebra 2 with trig. This is the review for 2b.1 through 2b.4, the review. Working with exponents. Here we're dividing the same base, so we subtract exponents. So it's x to the fourth power. Here we're raising the powers to a power, so we would distribute the exponent through. Notice this is a binomial. Actually, this is a monomial. This is not a binomial. If it was a binomial, you could not distribute. This doesn't have a plus or a minus in between the terms, therefore it's a monomial. You can distribute your exponent. So we have -3, gotta have parentheses around that, x to the 6th power because you multiply, y to the -9th because you multiply, and z to the -12th because you multiply. Notice there's no pluses or minuses in between the terms. So you could leave it like that, or you're welcome to call it -27 x to the 6th. Because the y and the z have negative exponents, they go to the denominator. Again, for the same reason, they all have negative exponents, so they're all going to go to the denominator. Now they'll have positive exponents. You're welcome to call that 49 if you want, or you can just leave it 7 to the 2nd power. So the -3 goes to the 5 as an exponent. It goes to the g by multiplying its exponent. So anything with a negative exponent is going to go to the opposite side of the fraction. The h does not have a negative exponent, so it stays. So I write this in 3 different groups because they're 3 different kind of like terms. This can be divided by 3. So 3 goes into that 4 times, 3 goes into that 7 times. The a would go to the denominator, and the b would go to the numerator. Because it has a negative exponent, it needs to go to the opposite side of the fraction. And then you can kind of group together what you've got. On the top we have 4b to the 14th, and in the bottom we have 7a to the 5th. We have an x squared on top and an x to the 5th on top. On the bottom we have x to the -3 and another x to the -3. For the y's, we have y to the -8 on top, y to the 4th on bottom, and y to the -2 on bottom. So again, this can be reduced by a 3. We can move the x to the -3 on top, negative exponent to the top. So now we have x cubed, x squared, x to the 5th, x cubed. The negative exponents go to the opposite side of the fraction. If you have a positive exponent, you stay put. And if you have a negative in the denominator, you go to the top. So we have 7 and 6, which is 13 exponent for the x's. We We have 2 on top, 12 on bottom. That's going to give us 10 on the bottom for the y's. And the 4 is on the bottom. No need to write the 1 on top. Here we're going to add 2 different polynomials together. So the f function is negative 5x cubed plus 3x squared minus 8. The k function has a 4x cubed and negative 15x and a plus, try to get that in the same row here, plus 14. So I just tried to line them up the best I could in terms of their like terms. So with their like terms, with the same exponents, you don't change the exponents, you just negative 5 plus a 4 gives you a negative 1. You don't need to physically write the 1. This is a function squared, so we look at the m function. And we square it. We substitute in the mx inside the parentheses. Then to square it, we're going to have to write this twice. This is that situation where you cannot distribute. Very common mistake. We talked about it earlier, and we see it now that you cannot distribute that. Yes, you would get 9x to the 4th if you distributed it, but you wouldn't get the 15x squared and then the 15x squared. You'd be missing that 30x squared sitting in the middle. So this is 9x to the 4th plus 30x squared plus 25. Now we're going to subtract. With subtracting, we have the g function. We're going to subtract the f function. It is required to put the parentheses around the f function because you're subtracting that entire function. And when you subtract that entire function, we have to distribute, and that's what the parentheses tell us to do. We're subtracting each one of those. So we're going to have negative 6. Let's see, let's put this in order just to help organization here. We have x cubed, the largest exponent, then negative 6x squared, and negative 15x. Then we're going to have a positive 5 x cubed and negative 3x squared and a positive 8. So this is 6x cubed minus 9x squared minus 15x plus 8. The j function and the k function distribute through. We have x to the first power, x to the third power. The 3 and the 1 make 4. So I took the x and I multiplied it to all 3 terms. Now I take the negative 6 and I multiply it to all 3 terms. Negative 6 times 14, we get 2 of those would make 28. Another 2 would make 56, and another 2 would make 84. your x to the fourth would go first, and then your x to the third would go next. I'm just kind of crossing them off once I use them. Your x squareds would go next. Then your x's would go next. And your constants will go last. The h function, see how it says a dot representing times multiplication? The m function, so we just FOIL this together. X and x squared gives you x cubed. 2 and 3 make 6. And then we'd write them from smallest, or from the largest exponent to the smallest. Doesn't look to have any like terms to combine. Here we're going to subtract, so we got the g function. Minus the k function. We have to use parentheses around a k function. So it reminds us to distribute that negative through. So I'm going to have an x cubed, a negative 6x squared, a minus 15x, a negative 4x cubed. I can put that underneath if I want. A negative 15, add positive 15x, and a negative 14. I don't have any x squareds involved with the k function. So this becomes negative 3x cubed minus 6x squared. They cross out completely. Minus 14. Next we're going to square a binomial. Remember, you cannot distribute the square through. You have to write it 2 different times. Then we FOIL it. So that's 36x squared minus 36x plus 9. These are conjugates. They have the same numbers, but opposite signs. That means the middle terms are going to cross off when you FOIL it. You get a negative 21x and a positive 21x. Those are going to cross out. That's going to happen every time you're working with conjugates. So 49x squared minus 9. Now, this is a crazy one. Now, the intent of this one is to use the binomial theorem. The Pascal's triangle. Pascal's triangle, you can see what the 5th row would be. Because you have a 5, you're going to work with the 5th row. 3x next to every one of those. Because that's your A term. Put your B term next to that. And we put pluses in between every one of them. So then with the A term, because it's the fifth power, we put a 5, a 4, a 3, a 2, and a 1, and you have to the 0 power. For the B term, you have 0 of them. 1, 2 as an exponent, 3, 4, and 5. Look at the pair of exponents. They always add up to 5. The A term, 5, 4, 3, 2, 1, 0. The B term, 0, 1, 2, 3, 4, 5. Okay, that's the binomial theorem. That's the pattern that's made up when you do craziness like this. So next, all we have to do is simplify this. Clean it up. So we're going to have 3 to the 5th power, x to the 5th power, 3 to the 4th power, x to the 4th power, negative 4y, 3 to the 3rd power, x to the 3rd power, y squared, and y squared is going to make the negative go away. A cube, negative, negative, negative is still going to be a negative. To the 1st power doesn't change it. To the 4th power is going to turn that to be a positive, y to the 4th power. And this one just becomes negative y to the 5th. Well, you could put the 5 inside, I guess. Now we get 243 x to the 5th. We're going to get 3 to the 4th power, and that's going to be multiplied by 5 to give us 405 x to the 4th. Now this is a negative y, so the negative can be put in front of the 105. It's like a negative 1, and negative 1 times 5 is negative. So here we have 9 times 10. This would be a negative, so we put a minus down. 10 times 9. Oh, let me look back here for a second. This would have been 27, not 9. This would have been 27 times 10. But here would be 9 times 10. X squared, y cubed, 15, minus y to the 5th. So that pattern is called the binomial theorem. Notice that the exponents go 5, 4, 3, 2, 1, and no x's. And for the y's, there are no y's. Then there's y to the 1st power, y to the 2nd power, y to the 3rd power, y to the 4th power, y to the 5th power. And the coefficients, they're all made by multiplying what we had as the 5th row of Pascal's triangle. And then we had to raised to the power of our a term. If you weren't going to use Pascal's triangle and the binomial theorem for this, it would be quite a process to multiply that out by hand. But you can do it. You can multiply this out by writing it 4 different times and distributing all the way through every time. But let's try binomial theorem again. We're going to use the 4th row. So the 4th row is 1, 4, 6, 4, 0. Then you put down your a term. Your a term is the first term. Your b term, because it's a 4, we're going to put a 4 on all of the a's. Well, 4, 3, 2, 1, and 0 of them. This would be 0 of them. 1, 2, 3, and 4. We always put a plus in between. 2 to the 4th power. 2 times 2 is 4, times 2 is 8, times 2 is 16. A to the 4th. That would be 8 times 4 is 32. 32 times 3, 96. A cubed, b to the 1st. This is 4 times 9, which is 36. 36 times 6 is 216. 2 times 27 times 4 again gives us 216. A, b cubed. And then here's 1. Anything to a 0 power is 1. 3 to the 4th power is 81. So you can see how Pascal's triangle and binomial theorem really make multiplying this out a lot easier than if you were to do it just by writing it out the long way. If you would like to see it worked out the long way, okay, so this would become 4a squared plus 12ab plus 9b squared. And we'd have that twice. Because this would FOIL to be the exact same thing. Now, we have to multiply to get 16a to the 4th, because a squared and a squared. 4 times 12 is 48. A squared times a gives you a cubed times b. And 4 times 9 is 36. A squared, b squared. Now I'm going to multiply through with the 12. So the 12 times 4 gives us 48 also. A cubed b. 12 times 12 is 144. A squared, b squared, because a times a is a squared, b times b is b squared. And 9 times 12 is 108. And then we come through again and we do it with a 9. We take the 9 and we multiply it all the way through. So this would give us 36 a squared b squared. A squared times b squared is a squared b squared. Another 108 a b cubed. And then 81 b to the fourth. We group those together. 16 b to the fourth plus 96 a cubed b plus 216 a squared b squared plus 216 a squared b cubed plus 81 b to the fourth. So it's doable. You can multiply it out. Notice the extra lines compared to binomial theorem. Notice the pattern. We have b. Oh, I'm sorry. I think I did this in class too. That's an a to the fourth. This should be a to the fourth. This is a 16 if you can't read that. 4, 3, 2, 5 like that. It's good to check your work. A to the first power. And then the b's, there's no b's. B to the first, b to the second, b to the third, b to the fourth. So that is how we would multiply it out without using binomial theorem. Number 15 with a 5, that would be pretty crazy. You would end up getting this, something similar to it, but you would have a whole nother term, the fifth one, to distribute through. You'd have 10 calculations to go. It's doable. Notice how we got the same answers with binomial theorem as we did multiplying them out. Okay, long division. Notice that I put a 0 to represent the term that we didn't have. That just helps with organization. Take your first term. And you take your first term and divide it by your first term here. We get 8x. So I'm going to put that 8x in the x column. Then you multiply through to everything. X times x squared is x to the third. 8 and 1 is 8. 0. And then negative 24x. Then we need to go through and change all of the signs. So that's going to make this 5x squared plus 12x. Bring down your 10. We take our leading term divided by our leading term. Leaves us a 5, a positive 5, and you distribute that through. Then you have to change the sign. Now notice I circle my new sign. Don't just change a negative to a positive or erase to make it a minus. Put in your new signs and circle them. Your first terms are going to always cross out. That's why we chose the 5. So our division, the answer to division is a quotient. So the quotient is 8 plus 5, and it has a remainder. And we write that over the divisor. We're going to do this in long division format. You have to put a 0 in for the x squared. There is no x squared. So we've got x cubed divided by x. So we're going to put the x squared in the x squared column. When we multiply, we get x cubed. Change the signs and circle them. First terms will always cross out. Take your first term, be a negative 3x. Notice that's in the x column. So negative 3 times 3 gives us 9x. We have nothing to go in that last spot. So this is, well, we got to change our signs. Don't move too fast here. So we get 9x plus 30. So x squared minus 3x and 9x plus 30 divided by x plus 3. Here we have Amazon, and we're selling graphing calculators. You open an Amazon Prime account and purchase a graphing calculator. You get $25 off of any graphing calculator, and you save 20% off your purchase when you open a new Amazon account. So what are your two functions going to be? Write a function f to model the $25 off. So f of x is going to be the cost of the calculator minus $25. Then we write a g function, which is 20% discount. So one way you can think about it is x minus 20% of your cost, right? So when you factor out your x, this comes out to be 0.8 times x. So we often just talk about if there's a 20% discount, you can just call it 0.8. That's 20% off of 100%. Use the composition of functions to find the purchase price of a $125 calculator when the 25% discount is applied before the 20% discount. So what we're doing here is g of f of x. We're doing the 152, and we're going to minus the $25 discount first. So this is going to be 127. And then from the cost at 127, we're going to do 0.8 of that. So we had 152, and we minus the $25, and then we're going to times that by 0.8 because we get, or we pay 80% of the price. So we're going to pay a total of 101.60. Now if we try it in the other direction, use composition of functions to find the purchase price of a $152 calculator when 20% discount is applied before the $25. So the 20% is applied first. So this is f of g of x. So we're going to take our 152 and we are going to apply the 80% to it. So that gives us 121.60. Then we take our 126 and minus $25 from it. We're going to pay $96.60. So notice the two prices were different. So the question is, why is it a better price? If we did the same thing, we took $25 off and we paid 80%. But if you notice, we paid 80% of 127. Here we paid 80% of 152. We subtracted $25 off some amount, so that was equivalent. But what made the difference between the prices is taking the 80% of a larger number, 80% of a smaller number. That means there was less discount in that situation. Let's see. Let's use the term of the 20 so it stays equivalent. Take 20% off at a larger price will give a better discount. So we took 20% off, which is 80% of a small number. Here we took 80%, which is 20% off of a larger number, and that led us eventually to a better discount. So if we're going to do synthetic, we have to figure out what our zero of the function is. And we put down our coefficients. If one term wasn't displayed, we'd have to put a 0 in its spot. Drop down the first term and multiply. Add these together, multiply, add these together, multiply, add these together, multiply, add these together. So, what we end up getting here, this is a fourth power. We're dividing to the first power. That means we're going to have 1 degree less. So instead of a 4, we're going to have a 3. And these are your coefficients. Minus 5x squared plus 0x plus 6. And there is no remainder. So we'll take our x plus 1 equal to 0. We get negative 1. We use negative 1 just like we did in synthetic substitution. This is x to the fourth, that's its coefficient, x cubed. There is no x squared. There is no x, but there is a constant. Bring down your number and multiply. multiply, multiply, multiply. So this is x to the fourth. So we're going to say x cubed, x squared, x minus 3, plus we have 7 over our divisor. So now we're going to come down and do compositions. F of x. So we take our f function, which is negative 4 times something plus 15. That is your f function. Now you plug, in this case, you're actually plugging the f function into the f function for the x. So there is no x the way we write it first, and we put the f function inside of it. Distribute to get 16x plus 60 plus 15. That would actually be minus 60, right? Negative 4 times negative 15 is a negative 60. Take the g function, which is 2 times something minus 7. Plug the m function inside of the g function. It's not multiplication. We don't FOIL anything together. We might need to distribute. The m function, negative 6 times something plus 8. This something is like your x, but instead of plugging in a number, we're actually going to plug in another function. So we distribute through. And there's no like terms to combine, so we're all set. So look at the number or letter that's out in front. We make our main equation look like that k function. So the k function is something to the 5th power. So we're going to put the g function inside of that. So what we had learned about to the 5th power. Let's see if we can fit this in here using the binomial theorem. You would not be expected to multiply this one out by hand. You would not be expected to write parenthesis, 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 parenthesis. So we have a 1, a 5, a 10, a 10, a 5, and a 1. Put in your a term. Put in your b term. I would suggest to put pluses in between and let the negatives take care of themselves. Now for the exponents. Notice that this is a 5th power. So we put a 5, 4, 3, 2, a 1, and a 0 over the a terms. Then for the b terms, we put a 0, a 1, a 2, a 3, 4, and a 5. Now we start grouping them together. So what this is 2 to the 6th power. So 2 to the 6th power is 64. X to the 6th. Negative 7 to the 0 power is just 1. You can write 1 if you want, but you don't need to. This is a 5 times 2 to the 4th. 2 to the 4th power is 16. X to the 4th times negative 7. So negative 7 to the first power is still negative 7. We have 10 times 8x cubed times 49, because negative 7 squared is 49. Plus we have 10 times 4x squared times negative 343. This becomes, I'll actually multiply this out. This is 10x. This is negative 7 to the 4th power, which is a positive 2401. Then we have 0, 0, and we have negative 7 to the 5th power, which is crazy. Alright, well, there's nothing to do with the 64x to the 6th. Here we get 5 times 16 times a negative 7, which is actually a negative 560 x to the 4th. This is 10 times 8 times 49. That's x cubed. This is going to have a negative involved with it. So 10 times 4 times 343. This is 10 times. That's an extra 0. And then it's just 16807. So without the binomial theorem, this would be insane. You would not be expected to solve this without the use of the binomial theorem. The p function, which is 4 times something cubed minus that same something plus 12. So the k function is x to the 5th. So we put x to the 5th inside every spot that the p function has an x. So this becomes 8. So 4x to the 8th minus x to the 5th plus 12. Here, if we're going to evaluate, you could either do what is p of f of x and then plug 2 in, or you can just go to right to what is f of 2. The f function is negative 4 times 2 plus 5. That's negative 8. It's not plus 5, but plus 15. Gives us 7. Then we go to the p function and we plug in that 7 to the p function. Well, the p function is 4 times 7 cubed minus 7 plus 12. So 7 cubed, we did earlier, which was 343, times 4 minus 7 plus 12, which is 5. So p of f of 2 would equal 1,377. So h of 4, the h function is 5 times something squared. Oops, not 2. That was the previous problem. It's 4 plus 3 times 4. Now you don't say 5 times 4, you have to square first. So this is 5 times 16 plus 12, 80 plus 12, which is 92. Then we'll do j of 92. The j function is something squared. So the 92 squared gives us 8464. And the last one, the p function, p in -1, the p function is 4 -1 cubed minus a -1 plus a 12. When you cube a -1, you get a negative. And a negative times a negative is a positive. So this is -4 plus 13. So this is 9. So m of p of -1 equals 9. And over here, this was the j of h of 4 equals 8464. Good luck.